Okay, welcome to the class. Now start the session. So if you are seeing this one, please tell me either you are seeing the screen or not. If you are not seeing, please tell me, is there any disturbance in the screen or you are not in clear in the screen? Just tell me. Are you unable to see the screen, students?
Yes, sir.
Okay, that's good. So please all of you mute yourself once again. Okay. So today we will going to discuss the few objectives. Okay, today class objectives are level of voltages and electrical installations and dielectric materials here. So we are in the class, that's the subject name is the high voltage engineering. Okay, so here in the high voltage engineering, so here what is the high voltage engineering and what is the level of voltage? Okay, before going to that, so we'll take the, so what are the levels of voltages? Okay, we are having the different level of voltages. One is the low, medium, high, extra high voltage, okay, ultra high voltages. Okay, so based upon the level of voltages and magnitude values, the voltage levels are different. Okay, the low voltage, medium, high, extra voltage. Okay, so what are the extra voltage, what are the low voltage? Okay, so in the low voltage applications we are using the, that is a domestic applications, we are using the low voltage applications. Okay, and the medium, that is a, it will coming to the medium applications, it may we can say that the three phase applications whatever is running in the industry. Okay, that is coming to the uh, medium application. Okay, so in the high voltage engineering, okay, in the high voltage engineering, if you go for the 33 kV above, okay, so that is also called as a high voltage engineering. So above that voltages are, you will go for the high voltage. Okay, so here we'll go for the, what are the mainly using the high voltage. Okay, so here mostly we are using the 440 volts as considered as in the high voltage. Okay, so if you extra high voltages, okay, so extra voltage is there. So let us check voltage levels, so for consumers, for domestic applications and industrial applications. So here we're having the AC power with the frequency. In India we are using the 50 hertz frequency. Okay, and plus or minus 50 plus or minus 5%. Okay, we are having the domestic applications in the 220 volts. If coming to the foreign countries, they are using the 110 volts 60 hertz frequency for single phase. If we take the another voltages, okay, that is the 440 volts, 3.3 kV, 6.6 kV, 11 kV in case of three phase. Okay, so we're having this much of voltage levels. Okay, so here 440, 3.3, 6.6, 11 kV. So these are the coming to the either the, all these are in a three phase. So here, so if you take this one, the single phase application, that is the 110 volts, 220 volts are the single phase. So remaining, that is 440 to above, so all are the three phase for the AC application. Okay, so here coming to the traction. Okay, here in the MMTS trains we can see that, so they will having the one only one wire on the above the trains. Okay, mounted with the H type H type holders. So here, so at for that one we are using the 25 kV single phase supply. Okay, so that is another thing. Okay, so they are using the single phase supply by using the booster transformers. So we can see the booster transformer in the middle of the track. Okay, for a fewer kilometer there will have one booster transformer will be there. So that is a track as used as a one revenue. Okay, and so here the frequency will be different for traction, and the frequency which we are using for domestic applications in India, that is also different. Okay, so here in the domestic applications we are using as a 50 Hz, but coming to the traction, that is the 25 kV, so there is using the less frequency. Okay, so based upon the how what is the voltage levels we are using. So coming to the generation, so here generation we are having the three-phase synchronous generator. Okay, so we're using the synchronous generator which will having the at same. So that is the we are having the different types of generators, that is non-conventional energy sources, non-conventional energy sources. If you take the conventional energy sources by using the hydro, nuclear, thermal power plants. Okay, at this situation we are using as a synchronous generator. So synchronous generator, what we are doing there, here the synchronous generator which you are using, so that will give the 440 for domestic application. If you take, so if you want to use a three-phase generator, that is a 440 volts. If you using the industrial purpose, okay, for a plant which you are using, okay, for industrial purpose they are using the 3.3 kV, 6.6 kV and 11 kV. So in India, so we are using as a all some of the generator which are having the nuclear, thermal, hydel power plants having the 11 kV. So some cases only we are using the highest power generation is 3.33 kV generation. So India, most of the generators are the 11 kV generators. Okay, the small generators, that is 3.3 kV, 6.6 kV. Okay, so we'll be using the 6 for generation purpose for three phase. Okay, for single phase we are taking from the rating as a one neutral, another one as a phase. So here we are another generations also there above 11 kV, so 21.5 kV and 30. So here we can observe that, so 11 kV, 110, 220. So what these means here, if the turbines is rotated, okay, so turbine and along with the generator. So here in the India, most of the having the so combined. So if it is single generator, if it is there, so 11 kV single generator highest is having the 110 megawatts as well as 220 megawatts. Okay, so motors also using uh, so we can usually we can read that. So in the Kaleshwaram project, they are using the 33 kV motors for production in the generative water power plant. So water plants are not power plant, in the water plant. So they are using the 33 kV motors. Okay, so here some, if the voltages voltages increases, okay, so what will happen, the current also will be increased. So similarly, so due to that, so what will happen if it is voltage is increased, so it will take the some insulation is required. So to do that, some insulation is required, so that's insulation will be getted by the these topics. Okay, so to control and protective, so we need this some equipment, okay, for wires and conducting material. At that voltages we need the suitable material. Okay, what are the suitable material, either gas material or dielectric materials. So we are having different types of dielectrical, gas, liquid, solid. So in that, so which type of insulator we are using, which type of insulation we are going to using in the generation, that we are going to discuss in this forward classes. In the coming to the distribution, here we are having the three phase. So in the distribution also we are having the three phase. So 440 volts I also having. So and 3.3 kV, 6.6 kV, 11 kV, 33 kV, 66 kV are there. Okay, and so here what will happen, the if it increasing the power consumption, okay, so the power distribution voltage also will be rise. So we daily we are using that. So whatever the, if you take the 10 years back, the distribution is very less. Okay, so nowadays everywhere is the power wires will be going. Okay, so distribution is increasing to need the consumer. Okay, so whatever the consumer needs are to fulfill that, so they are going to using the different distribution methods. Okay, so from radial to closed loop. Okay, so we have different types of distribution methods. So due to that, they are going to do the different methods. Okay, at that time if it is the less voltage is there, okay, nothing. So if you are going for higher voltages in the distribution, so to have to control the that current equipment. Okay, so protective equipment will be there. So to for that one we need the some insulation material. Okay, here if you take these some examples, in Germany 440 volts, 3 kV, 6 kV, 10 kV, 30 kV, 60 kV. Okay, so here I think you already know about the why having the Germany having the different countries, and USA having the some other voltage levels and frequency level. Okay, so in the power system generation you already know that, I think. So if you did not, so please go to the again search in the Google, you will get. So or else if you did not know that, I will discuss in the next class. So here for transmission line, we are having the long transmission line. Okay, so what happened the 110 kV, 132 kV, 220 kV, 400 kV, 500 kV, 765 to get. So in general we are listen that only 400 kV we are doing. Okay, so above, okay, from this one 500 kV to 765, so we are going to using this one as a DC transmission line. If it possible as a, they are going to using the AC transmission also. Okay, so based upon the distance and requirements, okay, they are going to use either AC or DC. Okay, so these are the extra high voltage engine. Okay, so whatever we're having the 500 for above 400, so they are called as a extra high voltage engineer. Okay, EHVAC. Okay, so HVAC means whatever having the, okay, so above 132 to 400, that is also HVAC. Okay, EHVAC means above 400, so whatever the voltage, that is a EHV, extra high voltage AC transmission lines. So we are having the, in India they are going to build in the 765 kV transmission line. Okay, so in only India we are having 765 kV transmission lines. Okay, in other countries we are having the 800 kV, 1000 kV, and 1150 kV also. Some areas they are having the existence. Okay, so here some cases they are going to using the 1500 kV also is there. So they are going to take if transmission lines there, so to they have to protect the equipment. Okay, at that time it will take this some complication with that. So they are going to the how to, you have to expand this 1500 kV transmission line. Okay, they are working on that. Here in the three-phase power system, the rated voltage is always given as a line to line. Okay, so if you observe that, so it's the 110 kV, 132 kV, 220 kV, 400. So these all are the line to line voltage. Okay, as well as RMS volts. So if you take the uh, RMS voltage, phase voltage, so that will be different. So here whatever the voltage we are placing, okay, so all are called as a RMS voltage, root mean square values. Okay, so whatever we having, if it want to find the phase voltage, we have to do the by root the values. So whatever the voltage is that we have to do with the by whatever the phase voltage is that we have to get the by root we will get the phase voltage. Okay, so here uh, for DC transmission line. Okay, so we need the single pole, and we are having the different types of uh, transmissions. One is we can use the single pole transmission line or bipolar. So in the single pole and bipolar, okay, so single pole also called unipolar method also called. So here in the DC transmission, we are in the single pole, we are using the only one wire used as a conductor, and will transmit the 500 kV, 750 kV. Okay, also then. Okay, so for bipolar we are using the two wires for two different. Okay, So that is a 500 kV also there in DC transmission line. So here you can observe the AC transmission line. So which type of towers we are using for transmissions. Okay, so you can by seeing the tower structure, you have to observe which type of voltage will they are going to transferring from the conductors. Okay, we are having the, you can observe the here height of the towers and what are the voltages we are using. Okay, so if you take the 66 kV, it is having the below 30 meters. So and if it 132 kV is there, we have it between the 30 to 40 meters. Okay, so here we are having the different structures of the level of voltages along with the height. So while seeing the in the outside, so you can observe that by seeing the structure of the uh, tower, so we can observe that it will having the voltage levels. Okay, here similar whatever they're having that, so is a common type different whatever the in feeds. Okay, here we are having the some other countries that are having the 110 volts. So what is why other countries having the 220? Okay, so US, Canada, Japan having a single phase AC supply 110. So why we are going others having the 220 kV? So here there is a advantages having over single phase 220, okay, compared to 110. So 110 volts having the higher advantages compared to 220, but some disadvantage also will be having while taking the 110 volts. Okay, so uh, here in India, why we are using the 220 volts AC supply or 220 to 230 volts. So there will be we can see that sometimes it will be fluctuated from 220 to 230. So here, so whoever the British rulers are there, they are going to be at the age, so where the they are ruled whatever the places they rule. Okay, so they want to use their products. Okay, so that's why they are going to be whatever what they countries having the okay voltage ratings, same voltage ratings are built in the power plants. Okay, they build the same power plants, that is whatever the ratings having the voltage fluctuation. So if it is British having the 220 volts rating the domestic consumption, so they are build the same appliance whichever require the 220 volt. Okay, so if we wanted to if they think that, so if we wanted to go into the other country rule, so we have to sell that product, so there might be a power need. Okay, so at that time we need the, so whatever the product is there that will be used, so for that one the voltage will be same at that nation also. Okay, so that way, so in the so many countries are having the 220 volts. Okay, so you can see in this picture which country having the 230 volts or 50 hertz. Okay, 240 volts, 50 hertz, 115. Okay, here you can see the most of the countries having the 220 230 volts, 220 volts, 50 hertz. Okay, some cases will having the, you can observe 110 volts, 50 hertz, 120 or 50 hertz. Okay, so in this picture we can easily know that, so which country is having the what are the voltage levels and frequency. So if you take the example, so if you talk about the 220 volts or 110 volts. Okay, so what will happen, so 120 110 volts, what will happen if you use the 220? So which one having the more dangerous, which one having the less dangerous? Okay, so if you talk about the, suppose if you are having the outlet is nothing but power socket. Okay, so whatever the charger is there, you are going to put in the power socket. If you take the example, so wiring is, so if you take the power socket having the 220 volts, because there is a less current than 110 volts wire. Okay, so in general we are having the 220. So if we connect that one is the 110 volts wiring. Okay, so then what will happen? So if measure the power. Okay, so to achieve the 900 of watts of power, so we need the 4 amperes to be required in 220 volts of wiring. Okay, so if it is run the one motor which will having 900 watts, that may be consumed the 4.1 amperes. Okay, so that maybe it will be suitable for the 220 volts. So whereas if you use the 110 volts, 110 volts, same that wiring, so what will happen, will take the 8.2 amperes. So in that case, in the case of 110 volts, so here the wiring may be damaged. Okay, so wiring may be damaged, so the current is whatever they having, so it will having the, it will damage the total conductors. Okay, there is some problem. So while both here, both amperes and voltage can be pose danger, such as electrical shock. If you having the electrical shock, if you having the 220 volts, will get the, if it is affected by the 4.1 amperes. So if you get the electrical shock in 110 volts, what will happen? Will get the more severe cases. Okay, it may be burn the skin also. Okay, so whatever the consequences will there, what will happen, the danger. Okay, you can see in this manner. Okay, here what are the disadvantages are there compared to 110 volts. Here the disadvantages. So you can see in the disadvantages. Oh, this is for reference, not okay. So you are coming to this one also. Okay, for your reference only placing. Okay, now coming to the our topic, that is types of dielectric. So in the first chapter we have the types of dielectric materials, gaseous materials, next solid materials, and some insulating materials will having. So here we have the different types of dielectric materials, that is gaseous dielectrics and vacuum dielectrics and liquid dielectrics. So here in the gas we are going to discuss in this class these four types, that is gases, vacuum, solid, liquid. Okay, so here in the gas, so here all insulators are not dielectric. Okay, remember, all insulators are not dielectric, but all dielectric materials are the insulators. Okay, remember. Here in the coming to the gases dielectric, so we are having whatever the atmosphere condition, so we are having different types of gases. Okay, oxygen, hydrogen, helium, lithium. Okay, not lithium, hydrogen is there. Okay, so nitrogen also there. In that cases we are going to using the nitrogen and sulfur hexafluoride. Okay, which will having the electronegative gas, it's also called as electronegative, that is SFC gas, we are going to using the circuit breakers. Okay, so these gases, that is nitrogen and sulfur hexafluoride, that is SFC gases, we are going to use as a dielectric material. So if you having the nitrogen gas in the air, sir, why won't you directly use that nitrogen gas in the circuit breaker? Okay, so here let me take the example. If nitrogen gas, so we will having the atmosphere, nitrogen gas is the 70% is approximately. Okay, so it is a freely available. Okay, so here what they do that, so from the nitrogen gas generators, so they extract the nitrogen from the materials. Okay, some chemical composition, they will extract the nitrogen gas and they'll do the in the, they fill in the tanks. Okay, so nitrogen tanks. So at that stage, so what they do, they're using for the some liquid nitrogen is for the cooling purpose as well as insulation purpose. Okay, remember, so sometimes they use for the cooling purpose, sometimes they were using the liquid purpose. Okay, as a insulation purpose. Okay, uh, so here if we coming to the nitrogen, okay, if we take the one conductor, So whatever the nitrogen is, if you take the pure conductor, okay, if you whatever the conductor is, if this conductor is there, if you pour the pure nitrogen, okay, whatever the liquid form of the nitrogen, if you pour on the conductor, what will happen? It will act as a pure superconductor. Okay, if you use nitrogen on that one, it will act as a superconductor properties will be there. Okay, so here high pressure, okay, we are going to nitrogen and sulfide in the, we'll fill in the tanks and we'll be going to pressurize them, okay, atmosphere. So in the circuit breaker we are going to using the high pressure and sulfur. So here circuit breaker is nothing but as like as a fuse. Okay, so here's whatever the fuse is here. Okay, so fuse will be do the from here is the incoming line, here is the outgoing. So whatever the fault is occurred, okay, if fault is occurred on incoming, so that will it will be break down the healthy section to fault section. Similarly in the transmission line, if it is faults occur, if we wanted to isolate the healthy section to fault section, we are going to using the isolator. Okay, for higher voltage levels we are using the circuit breaker. So as like MCB, okay, miniature circuit breaker. So MCB is as a one of the circuit breaker, that is a miniature circuit breaker. So here in the circuit breaker, whatever the arc is produced, okay, while isolating the two contacts. Okay, so if it is having the healthy section contact and fault section, so here we having the circuit breaker having the one chamber. Okay, in that chamber whatever the here is there. Okay, so if it is first situation, they are going to connect. Okay, so whenever the fault is occurred, okay, so if fault is occurred, what they do, so they are going to separate this conductor. So we have to separate the two conductor from healthy section to fault section. So at that situation what will happen, so it will form the one arc in that one. So these arc is act as a conductor in that area. Okay, so in that air it will act as a conducting part. So if it is faulty, if want, we have to remove these arc. Okay, to remove this arc we are going to using the nitrogen and SF6 with the high pressure. Okay, from the SF6 tanks, okay, and nitrogen tank. So we are going to pressurize that and we are going to remove this arc whenever the fault is occur. Okay, that cases we are going to use in the gases dielectric medium. Okay, now so here is a in the sulfur example, it is a mixture of CO2 and N2. So mostly we are using the circuit breakers, we are going to in the SF6 gas only in the gas. Okay, so sir, is a gas insulated substation will having the and system also. Okay, so GIS substations will be also there in the Hyderabad. So you are already all are aware of the Koti, right? So in the Koti areas from Koti to Narayanguda, so we're having the one Shantinagar Shanti theater will be there. So at the back side of that one, we're having the GIS substation. Okay, gas isolated substation. In that case, that will be the from the outside we can see the only that is look like as a one apartment, but inside that it will having the gas isolation substation. From that one, what is the gas isolation? Okay, how it will be conducted will be there. So you can, we are going to study in the another topic. Okay, now coming to the circuit breaker. Okay, so here whatever the circuit breaker is, so if it is coming to the maintenance, we need some maintenance will be required for circuit breakers. Here here whatever the circuit breakers is, we need to fill the SFC gas. So for maintenance we are going to do the frequent maintenance required. So here this one is the nitrogen gas circuit breaker. Here the coming to the vacuum circuit breaker. So we are having the liquid circuit breaker and gaseous circuit breakers as well as solid breaker. Okay, so here dielectric medium. Okay, so if coming to the dielectric medium, as a where we are using vacuum as a dielectric medium. So here circuit breaker. So in the circuit breakers we are in the SFC gas and vacuum. Okay, sometimes we are going in the oil also. Okay, not as a solid material will not using the circuit breakers. Okay, here in this one vacuum, liquid and gases act as a dielectric mediums. Here in the vacuum circuit breakers, here we have this one. In the vacuum circuit breaker, in the vacuum as a dielectric medium. So in that one, so here is the order of 10 power of minus 5 torr. Okay, the torr is nothing but a Pascal. So the atmospheric pressure, whatever the standard Pascals is there, so in that it will having the 10 power of minus 5. Okay, torr. Here it will have the provides the low, so provides excellent electrical insulation compared to the gases or liquids. Okay, so if you which one is better, either vacuum circuit breaker or gaseous circuit breaker? Here vacuum circuit is the most effective compared to the gas circuit breaker. Okay, so vacuum is mainly used in the circuit breakers. So here is a vacuum circuit breaker, how it will be. Here it will be enclosed, whatever the gas is there, so that will be extracted through the some devices, vacuum devices, and whenever the fault is occurred, okay, that will be extracted from this one. Okay, here the coming to the liquid dielectric medium. Okay, types of liquid dielectric medium. So here the dielectrics, if you take this example as a transformer, so in the transformer we're having the different, so it is the organic liquids that will be coming to the mineral oil. Okay, so transform composition of the mineral oil. Okay, so the sometimes it will have the synthetic, it is having also in the natural power. Okay, here having the some properties will have whatever the liquid materials is there. Okay, liquid dielectrics, we are using the transformers, capacitors and cables and circuit breaker. So if you take the transformer, we are liquid dielectric medium is nothing but a which will having the transformer tank, that is the transformer iron. So if you take the capacitors, in the capacitors we can see the liquid in some type of capacitors. So in the, if you having the different types of capacitor, that is paper ice in that in the capacitor we're having the impregnate paper as well as some liquid dielectric also will be there. In that we'll having the two contacts will be there in that liquid. In coming to the cables, okay, for higher voltage cables, okay, for higher voltage cables we are going to use near the cables. In that cables in between having the liquid. So if you observe the, if you take the any wire, okay, if you cut that wire you'll get the some liquid material. Okay, so whenever you're cutting the wire you'll get the some liquid. Okay, so but so as like water you can't see the liquid, but it will having this some amount of, okay, small amount of liquid there.
Huh?
Participants enough mic. Okay, okay participant, this is about the liquid. So the meeting will be end in the 5 minutes. Okay, so if meeting is end, so I'm going to use the same uh, link again, you have to join. Okay, so after that we are going to discuss the liquid dielectric materials and solid material. Okay, and we'll having the some quiz also there. Again we'll post the one poll. Okay, same pole will be there. Please answer once again. Okay. Okay, who are not attend the poll, please attend the poll now. You will have the 5 minutes of time. Coming to this one, here we are having the solid insulators. In the solid insulators, we are having the different types of solids. While coming to the compared to the liquid dielectric medium, other dielectric mediums. Okay. Here in the dielectric as a liquid dielectric medium, we are only using as a mineral oils, impregnate compounds that will be used. Okay, here uh, in this one, in this solid dielectric medium, so sorry, in the liquid dielectric medium, so in the transform oil test, okay, in the transformer oil test, in the circuit breaker, whatever the where the liquid material is there, so the design will be same in this way. Okay, so here two conductors will be there. So one is a fixed contact and the other is a movable contact. Okay, whenever the contacts will be released from contact one, so what will happen, the arc will be induced. Okay, to due to the high voltage currents, what will happen, the arc will be induced. So we have to remove this arc or quenching of the arc when we are using the some dielectric medium. It may be gas or liquid, it may be vacuum. So here in this case of this diagram, we are having the liquid, the transformer, two conductors are there. So we are going to quench this arc. So in the transformer voltage, we are going to increase the voltage. Okay, either insulating mediums breakdown or not, that will be checked. Okay, if it in case of circuit breaker, if it is fixed contact to mobile contact, if it is away from the fixed contact to mobile contact, so what will happen, the arc will be increased. Okay, at that time we have to high pressure. Okay, high pressure gas or vacuum will be increased. Okay, here here coming to the solid dielectric, so we're having the different types of solid dielectrics. So we are mostly using the all type of dielectrics in your hands on. Okay, so you can see the different types of solid dielectrics. Suppose if you take the pen, also is a one type of the dielectric medium. If you take the pencil, also it takes the one type of dielectric medium. Okay, so based upon the that. Okay, so it will be some are the insulators, some are the dielectric material. Okay, so these are the we are having the PVC, XLP, okay, ceramic, glass, rubber, resins. Okay, all are coming to the solid. So if you take the most, we are using the PVC material use it as the insulator. So why we are calling the dielectric medium is, so all insulators. Okay, so whatever the insulators are there. Okay, insulators comes to the dielectric. Okay, so some insulators may come. So all the dielectric materials are not insulators, but all insulators are the dielectric materials. Some cases it will be based upon the castings. Okay, here ceramics, glass, rubber, resins, plastics, polypropylene, impregnate paper, wood, cotton, mica, pressboard, bakelite, pressback, ebnon, teflon. Okay, so these all the material we are already seen, but we don't know what is the name of that. Okay, so let us see the and also we are having the nanomaterials in the solid dielectric also. Okay, they are going to develop the what under developed conditions only. Okay, here one is the XLP. So here XLP means cross-linked polyethylene. Okay, it is will be used in the insulation purpose of the cables. Okay, it will be in this one. So if you see the cable, okay, so it will be used in the one time this one here. Okay, so in this things we are seeing, right, So this will be based upon the level of voltage we are using the as a insulation material for the conductors. Okay, so Teflon sheet. So Teflon sheet is one type of insulating material mostly using the electrical appliances, okay, to insulating purpose. Okay, here this is the backlight. So in the backlight we are using all equipments, maybe you already seen in the house domestic purpose, in the lab also we are seen this is so we don't know what is the name, so it is a backlight. Okay, and if you see the in your domestic, so all the equipments whatever the plastic, if you think that this is the plastic, but so whatever the equipment is there, okay, that material is called as a backlight material. Okay, so ceiling rolls, whatever the holder is there, okay, all are the backlight material with the composition the plastic. Okay, here is another is the impregnate paper. Okay, so impregnate paper insulation will be used for the in the electric cable. So impregnate paper is nothing but the paper is immersed in the oil. Okay, and that is the insulating oil that will be impregnate, and that will be used for the this cable. Okay, these are the types in the solid dielectric material. Oh, here we're having the quiz. Okay, the quiz will be quiz link will be posted in the chart box. Please see the chart box. So coming to this one, here we're having the solid insulators. In the solid insulators, we're having the different types of solids. While coming to the compared to the liquid dielectric medium, other dielectric mediums. Okay. Here in the direct liquid dielectric medium, we are only using as a as a mineral oils, impregnate compounds that will be used. Okay, here uh, in this one, in this solid dielectric medium, so sorry, in the liquid dielectric medium, so in the transform oil test. Okay, in the transformer oil test, in the circuit breaker, whatever the where the liquid material is there, so the design will be same in this way. Okay, so here two conductors will be there. So one is a fixed contact and then is a movable contact. Okay, whenever the contacts will be released from contact on, so what will happen, the arc will be induced. Okay, to due to the high voltage currents, what will happen, the arc will be induced. So we have to remove this arc or quenching of the arc when we are using this some dielectric medium. It may be gas or liquid, it may be vacuum. So here in this case of this diagram, we are having the liquid, the transformer, two conductors are there. So we are going to quench this arc. So in the transformer voltage, we are going to increase the voltage. Okay, either insulating mediums breakdown or not, that will be checked. Okay, if it in case of circuit breaker, if it is fixed contact to mobile contact, if it is away from the fixed contact to mobile contact, so what will happen, the arc will be increased. Okay, at that time we have to high pressure. Okay, high pressure gas or vacuum will be increased. Okay, here uh, here coming to the solid dielectric, so we're having the different types of solid dielectrics. So we are mostly using the all type of dielectrics in your hands on. Okay, so you can see the different types of solid dielectrics. Suppose we if you take the pen also is a one type of the dielectric medium, if you take the pencil also it takes the one type of dielectric medium. Okay, so based upon the that, okay, so it will be some are the insulator, some are the dielectric material. Okay, so these are the we are having the PVC, XLP, okay, ceramic, glass, rubber, resins. Okay, all are coming to the solid. So if you take the most, we are using the PVC material used as the insulator. So why we are calling the dielectric medium is, so all insulators. Okay, so whatever the insulators are there. Okay, insulators comes to the dielectric. Okay, so some insulators may come. So all the dielectric materials are not insulators, but all insulators are the dielectric materials. Some cases it be based upon the castics. Okay, here ceramics, glass, rubber, resins, plastics, polypropylene, impregnate paper, wood, cotton, mica, pressboard, bakelite, pressback, ebnon, teflon. Okay, so these all the material we are already seen, but we don't know what is the name of that. Okay, so let us see the and also we are having the nanomaterials in the solid dielectric also. Okay, they are going to develop the what under developed conditions only. Okay, here one is the XLP. So here XLP is means cross-linked polyethylene. Okay, it is will be used in the insulation purpose of the cables. Okay, it will be in this one. So if you see the cable, okay, so it will be used in the one time this one here. Okay, so in this things we are seeing, right? So this will be one based upon the level of voltage we are using the as a insulation material for the conductors. Okay, so Teflon sheet. So Teflon sheet is one type of insulating material mostly using the electrical appliances. Okay, to insulating purpose. Okay, here this is the backlight. So in the backlight we are using all equipments, maybe you already seen in the house domestic purpose, in the lab also we are seen this is so we don't know what is the name, so it is a backlight. Okay, and if you see the in your domestic, so all the equipments whatever the plastic, if you think that this is the plastic, but so whatever the equipment is there, okay, that material is called as a backlight material. Okay, so ceiling rolls, whatever the holder is there, okay, all are the backlight material with the composition the plastic. Okay, here is another is the impregnate paper. Okay, so impregnate paper insulation will be used for the in the electric cable. So impregnate paper is nothing but the paper is immersed in the oil. Okay, and that is the insulating oil that will be impregnate, and that will be used for the this cable. Okay, these are the types and the solid dielectric material. Oh, here we're having the quiz. Okay, the quiz will be quiz link will be posted in the chat box. Please see the chat box